Okay, so another example that we did in class was this one, where it's a transformation problem. And now we're dealing with f of x equals 1 over x, and we're trying to turn it into this graph right here. And the main issue with this is that it doesn't look like 1 over x, not to me anyway. And so there's a little trick that we can do to make it look more like 1 over x. And I feel like coming up with this trick on your own the first time is not the easiest, but after you've done it once, then it's much easier. So the trick, right, my trick anyway, is use long division on g. So here we go. So the numerator goes on the inside. The denominator goes on the outside. And then if I work this out, really, in order to get 6x down here, I just need to multiply by 3. So it's 3 times 2x gives me 6x. 3 times 1 gives me plus 3. Most students remember this cancels and then put 1 here, right? But that's not 1. Remember, you got to subtract everything. So it's 6x minus 6x is 0. Negative 2 minus 3 is negative 5. So here's our remainder. But remember, you can always write these division problems this way. G of x equals, and then I'm going to put my quotient plus my remainder over the divisor. So in this case, it's going to be the quotient, which is 3, plus the remainder, which was negative 5, over the divisor, 2x plus 1. And I remember in class, a lot of people ask, can we write it this way instead? And that's totally fine with me if you just put the negative in the front. Okay, so now this looks a little bit more like 1 over x. Our parent function, f of x equals 1 over x. We're trying to turn that into this new function, g of x, in our new form, 3 minus 5 over 2x plus 1. So the general point for f of x is going to be a comma 1 over a. In order to make g of x have a general point that involves something that looks like 1 over a, the trick is, if you remember, is to take this ugly x term, quote unquote ugly x term, and make it equal a. So let a equal that. And then if I isolate the a, I'm going to, whoops, that's a plus 1. I'm going to subtract the 1, divide by 2, and that's my x. So therefore I get that. And now if I use substitution back into the g equation, it's g of x, which is really g of a minus 1 over 2, equals 3 minus 5 over, and in this case I've now rigged it so that denominator is a. So this means that the new point that I'm turning 1 over a into is going to be a minus 1 over 2. That's the x value. And my new y value is 3 minus 5 over a. And if you can't quite see how the 1 over a turns into this, you can also rewrite it as this instead. A minus 1 over 2, 3 minus 5 times 1 over a. Now it's a little bit easier to see, oh, the 1 over a gets multiplied by 5, then becomes negative, then you add 3 to it. So now it's just like one of our old problems that we did last chapter. In order to turn a into a minus 1 over 2, we're going to go horizontal shift left 1 unit. Then we're going to do a horizontal shrink by 1/2. And then in order to turn 1 over a into 3 minus 5 times 1 over a, you could multiply by 5 first, so that'd be a vertical stretch by 5, and then a vertical reflection in order to get the negative there. If you switch the two verticals that we've done so far, that's fine, doesn't really matter. And then we're going to add 3 to it, so vertical shift up 3. So here's what we get. Those are our transformations. Okay, so the other thing we need a couple of points on the new graph. So the way that I want to do it is I want to review what f of x looks like. So I'm going to do this. F of x again was 1 over x. So if you remember, that looks like this. There's this part going down along here, and this part coming across like this. And there are two main points that people often use. If I plug in 1, I get 1. And if I plug in -1, I get -1. And then there are two asymptotes. There's this asymptote, the vertical asymptote is x equals 0. And there's the horizontal asymptote, y equals 0. So if I go back through my general point approach, a comma 1 over a turns into a minus 1 over 2, comma 3 minus 5 times 1 over a. Then I can just apply this blueprint to figure out everything else that I need in my new graph. So this is for f, this was for g. So let's take a look at our points. First we got 1, 1. And that's supposed to turn into something down here. So 1, 1, in this, the first one is like a. So that turns into 1 minus 1 over 2, which is 0. And then this one is like the 1 over a. So if I plug that in for the entire 1 over a here, I'm going to get 3 minus 5 times 1. So that's -2. Then the other point is -1, -1. So it's a, 1 over a, and I'm supposed to turn it into a minus 1 over 2. So this is a. If I turn it into a minus 1 over 2, I get -2 over 2, so -1. And if I plug in this for 1 over a -1 right here, I'm going to get 3 plus 5, so 8. So now I got 2 points on there. If I look at the vertical asymptote, x equals 0, right? So x coordinates, that's kind of like saying, let's look at the point 0, comma, whatever. Doesn't matter what y is, only matters that x is 0. So if you think about what that turns into, this is my a. A is 0. So if I plug in 0 over here, then I get -1/2. So it turns into -1/2, comma, whatever. So if x is 0, now x equals -1/2. That's my new vertical asymptote. And the horizontal asymptote was when y equaled 0. So that's like anything blank, right, comma 0. So this is my 1 over a, which technically can never equal 0, but we can treat it that way using this blueprint, right? You take your y value and you do 3 minus 5 times your y value. Well, 3 times 5 minus your y value is 3. So we know that the horizontal asymptote has shifted to y equals 3. You could also get that by going all the way back to here. Remember, the quotient is always your end behavior asymptote, and the quotient's 3. So that's another way of getting it. Or you could say, like if you look up here, if it was originally at y equals 0, yeah, y equals 0, then the vertical stuff's going to move that around. So if I stretch 0 by 5, well, it's still 0. And then I reflect it across the axis, still 0. And then I move it up 3, now it's at 3. Right? The horizontal one was at 0 originally, so if I shift it left, now it's at -1. And then I shrink it by 1/2, now it's at -1/2. So you can also do it that way too if you wanted. So anyway, we've got all this information here. Now we can graph it. So here, I'll make my axes in black. And let's see, I got to go pretty high on the y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go -1, -2, -3, 1, 2, 3, -1, -2, -3, -4, 2, 1, 2. Okay, so I know the vertical asymptotes at x equals -1/2. X equals -1/2. I know the horizontal asymptotes at y equals 3. And I know that I have to go through the points 0, -2, and -1, 8. Okay, and if you look back at the original graph, you can kind of see how it hugs the asymptotes. The asymptotes really guide how this thing looks in this particular case. So you can guess that when I'm at negative 1, 8, it's going to come up and hug that asymptote, come down here, hug that asymptote. And then when I'm at 0, 2, it's going to do this. And there you go. That's what you have. So I hope that helps some.